This is the solutions to the mock paper, January 2008, GCSE. This is paper 1. So I guess we could call the solutions. Okay. Question 1. Work out the square root of 2 to the 6 plus 6 squared. Right. Okay, so what is 2 to the 6? 2 to the 6 is 2 times 2, which is 4, times 2, which is 8, times 2, which is 16, times 2, which is 32, times 2, which is 64. And 6 squared is 36. 64 and 36 is 100, so it's the square root of 100, which of course is 10. What is 800 million in standard form? Well, you should know that that a million is 10 to the 6. So 800 times a million is 800 times 10 to the 6. Now that's one of the answers, but the key is this: in standard form. And this is not in standard form. So to convert this to standard form, first of all, our decimal point at the moment is here. We need the decimal point to be such that this number is between 1 and 9 inclusive, or less than 10 and greater than or equal to 1. So we're going to have to move this 2 decimal places to there, to 8.00 or 8. But we are reducing this by dividing it by 100. In other words, we're moving the decimal point twice, making this smaller, and therefore we must compensate by making this bigger. So that is 8 times 10 to the 8. So our correct answer is this one. Let's draw that in blue to be consistent. Question 3. Circle the expression that is equivalent to 4a to the 5 all squared. So we've got 4a to the 5 all squared. And remember that in general we've got a times b all raised to the power n. We can multiply this out if you like, so it's a to the n times b to the n. And that's what we're going to do here. We're going to square each one of these factors. So this is 4 squared times a to the 5 squared. 4 squared is 16. And what do we do with these? We multiply these together. So this is a to the 2 5s of 10. 16a to the 10. So the correct answer is this one. Question 4. The value of x doubles. Okay, so if we're going to double the value of x, what happens to y? Well, if we're making this twice as big, okay, so we're dividing both sides by 2 by doing that. So then what's happening to y? Well, y is becoming half of its original value. Okay, so x is being doubled to 2x, which is the equivalent of multiplying by half, if you like. So if we multiply by half, then something halves in value. So y is half of what it used to be. Okay, from question 5a, factorize. You should immediately recognize this as a difference. Remember, subtraction is a difference of 2 squares. This is a square, and this is a square. Okay, difference of 2 squares, you should know straight away. We've got 2 brackets, one with plus, one with minus. This x goes here, and the square root of 100 goes there, which is 10, and the same with this one. So x plus 10 times x minus 10. Question 5b, inequalities. The important thing to remember about inequalities is you do the same thing as if this was an equal sign. So you can sort of pretend this is an equal sign. One thing that you must remember is if you multiply or divide by a negative number at any point, you flip over the sign. Okay, so let's remember, if you multiply or divide by a negative number, then flip the sign over. Okay, so let's see what happens here. So we're going to start off by getting the x's together, gather the x's together. So we're going to subtract this 2x from both sides. And we're not multiplying or dividing here. So subtracting something from both sides doesn't mean we flip the sign over. So subtracting 2x from both sides, we get 5x here plus 6 is greater than 1. And then we're going to simply subtract 6 from both sides. Again, we're not multiplying or dividing, so just subtracting. So we get 5x is greater than minus 5. Now we divide both sides by positive 5. So again, we're not doing any of this multiplying or dividing by a negative. So divide both sides by 5. We get minus 5 over 5, which of course is minus 1. So x is greater than minus 1. Question 6. Work out the value of root 3 squared times root 2 squared. Well, remember the square root and the square are just the inverse of each other. So they sort of cancel each other out if you like. So root 3 squared is root 3 times root 3, which is 3. And the same thing to the root 2 squared is just 2. You end up with 3 times 2, which is 6. Question 7. Quarter of a circle. Work out the area of the quarter of a circle. Remember, a whole circle is pi r squared. So our area here, let's call this our area, is pi r squared, but only a quarter of it, so we divide it by 4. And our radius is 6. This is pi times r squared, which is 6 squared. 6 squared is 36, so we get 36 pi divided by 4. Cancel down 36 and 4, which is 9, so we get 9 pi. Notice it says give your answer in terms of pi. You don't have a calculator, so unless you multiply 9 with 3.1415, blah, 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 blah. But you won't do that in a calculator, non-calculator exam. 9 pi. Question 8. 3 whole numbers are each rounded to the nearest 10. This is in bold for a reason. Whole numbers. The sum of the rounded numbers is 70. Alright, now we don't know what these numbers are. Okay? So let's pretend that the numbers are, so let the numbers be x, y, and z. Okay, we're told that the sum of the numbers, the rounded numbers, is 70. Right? So basically, what we've got here is if they're rounded to the nearest 10, they're whole numbers. They should have all been 4 more than what they could have been before. Okay, so if there were 5 more, they'd be rounded up. Okay, so for example, number, let's say 16, if that was rounded to the nearest 10, that would be rounded to 20. Whereas if it was 15, that would also be rounded to 20. So it must be 14 in whole numbers, rounded down this time to the nearest 10. So we're getting 4 extra. So 4 extra for each. And the 3 numbers give us 12 extra. So that implies we get 12 extra numbers. And if they're the rounded numbers is 70, add the 12, we get 82. So our answer is 82. Question 9. Circle the expression for the range of n consecutive integers. N consecutive integers. Well, integers are just whole numbers. So we could write down n whole numbers. We don't know how much n is, so we could just start with highlighting 1, 2, 3. And it's going to keep going until we've written n down. So it's going to end up at n. Okay, now what is the range? The range is the largest number, n, minus the smallest number, 1. So the range is n minus 1. So that's the correct answer. Question 10. 3 identical isosceles triangles. Okay, isosceles triangle, remember, mean that 2 of the lengths are the same. So this length is the same as this length, which is the same as that, which is the same as that. And of course, these are the same as well, because they're identical triangles. Right, each triangle has a base b and a perpendicular height h. Work out the expression in terms of b and h for the area of this trapezium. Well, the area of this trapezium is half the sum of the parallel sides. Remember, the area of a trapezium is half of the sum of the parallel sides times the distance between the sides. Okay, which in this case is h. So what are the sum of the parallel sides? Well, these are the parallel sides here and here. So this is b, and this, of course, is 2b. So the sum of the parallel sides is 3b times h. So that's our answer, 3bh over 2. Question 10b. We're now given a ratio. B in the ratio of s is equal to 2 to 3. Okay. Now, you must remember that ratios are just divisions. So I could write this as b divided by s equals 2 divided by 3. These ratio signs and the division signs are the same thing. Work out, in terms of b, only b, the perimeter of the trapezium. Okay. Now we're told that this is s here. Okay, and this, of course, is b, because it's the same as this one. This is b, this is s. So what we've got in total is that the perimeter is 3 b's and 2 s's. But we only want this in terms of b. We can't have s's in it. So we need to use this information to rewrite s in terms of b. So the easiest thing to do for that is to cross multiply here. Okay, so we're going to get 2s is 3b, and if we rearrange to get s equals to s is 3b over 2. So our p then is our 3b here, plus our 2 logs of 3b over 2, because s is the same as 3b over 2. Those two things are the same. So for this rectangle, both of those. These two cancel, and we end up with 3b plus 3b, which of course is 6b. Perimeter equals 6b. Question 11. 4 candidates in an election were A, B, C, and D. A, B, C, and D. A pie chart shows the proportion of votes for each candidate. Look at the probability that a person who voted chosen at random voted for C. We're trying to work out how large this angle is out of the total of the angles, which is 360 degrees. So our answer is 2x plus 10 over 360. But what is x? Well, how can we work out what x is? We know that all of these angles add up to 360. Okay, so we've got 90, that's this angle here, plus x, plus this angle 2x plus 10, plus this angle here 2x, must equal 360. So let's work with this a little bit. Let's do numbers first. 90 and 10 is 100. X plus 2x plus another 2x is 5x. Okay. Let's just check that. 90 correct, plus x plus 2x plus 10 plus 2x equals 360. I missed a 0 off there, that's better. Okay, so now we're going to subtract 100 from both sides to get 5x equals 360 take away 100, which is 260. So x is 260 over 5. And what's 260 over 5? Well, if we divided 260 by 10, we get 26, but we're only divided by half of that, so it's double 26, which is 52. X is 52. So this answer here, my answer, so my answer now is the value of x, 52, so 2 times 52 plus 10 over 360. 2 times 52 is 104 plus 10, 114 over 360. And that would give you full marks because it's not a question on fractions. Usually you should cancel down, of course, fractions, but in this case, it's fine to leave it like that. Question 12. Use approximations to one significant figure. Okay, so let's approximate this. So 0.526 to one significant figure is 0.5, not 1. 0.5, 0.5 times, and then 39.6 to one significant figure is 40 squared, divided by the square root of 97.65 to one significant figure is 100. Okay, so 0.5 times 40 squared is 1600, so half of 1600 is 800, divided by the square root of 100, which is 10, and the answer 80. Question 13. We're trying to work out x minus y given this information here. Now remember again, these ratios are just like divisions. So x divided by y, that's this ratio here, is 7 divided by 4. And we're also given x plus y equals 88. And suddenly we have got simultaneous equations. So let's rearrange this equation. Let's call this equation 1 and this equation 2. Rearrange equation 1 to get x equals. We're going to multiply both sides by y. So we're going to get x equals 7y divided by 4. So let's multiply both sides by y in equation 1. And we're going to substitute that into this equation 2. So we're going to substitute this x into here, which of course is the same as that. So what we get is 7y over 4 plus y is 88. And if we multiply both sides by 4 now, we can get 7y plus 4y is 4 times 88. It's 4 times 88. 88 is 16. 4, 8, 32. 2 can make 3. Y is 32 plus the 3, 35. So here we've got 11y is 352 over, sorry, 352, so y is 352 over 11 divided by 6. Okay, so if that's y, what is x? Well, what is 352 divided by 11? 11 into 35 goes 3, with 2 left over, and then 22 goes 2, is 32, so y is 32, and if y is 32, we can substitute y is 32 into 2, into this equation here, so we get x plus 32 equals 88, subtract 32 from both sides, and we get x is 53. And therefore, what is x minus y? That's what we'll try to find. Well, x is 53, y is 32. 53 minus 32 is 21. So the answer is 21. Simultaneous equations. It's quite a lot of work for 2 marks. There possibly are other ways to do it, but that's certainly one way. Question 14. Work out the number of sides in this polygon. Right, okay, so how are we going to do that? Well, this is obviously the area that we need to concentrate on. We know that all the way around is 360. Now 60 are taken up by this angle. So these two here must be 150 each, 150 degrees. What do we know? What do we know about the external angles? So the external angles add to 360. Okay, need to remember that. And what is the external angle here? Well, the external angle here is actually this angle, which is 30. Okay. And we don't know how many there are, but we certainly know that they add to 360. So if there are n sides, we know that 30n must equal 360. 30 lots of number of sides must equal 360, because this is at 30 degrees. So n must be 360 over 30, which is 36 over 3, which is 12. So there are 12 sides. A few people had answers like 5 and things like this. Well, we can quite clearly see 1, 2, 3, 4, 5 sides there. It's got to be more than 5. Question 15. Two triangles on a grid. Write down the column vector. Now remember, column vectors are vectors that look like this. There's no division sign in the middle. We have an x here and a y there. This is the horizontal displacement. In other words, the displacement is left and right. And this is the vertical displacement. So that's going up and down. Right. Write down a column vector for the translation that moves triangle P onto triangle Q. Now the easiest thing to do is just to take one corner and see how many squares it's being translated by. So here we go. Starting from here, we want to get to this point in the x direction. This point here. So let's see how many we've got there. So we've got 1, 2, 3, 4, 5. So the horizontal displacement, remember, right is positive, left is negative, and up is positive, down is negative. Remember that. So that gets us to this point, and now we need to go up. 1, 2. So up is positive. So 5, 2 is the answer. 5 across, 2 up. Translate triangle Q using the vector -4, -7. So this means we're going 4 left. So let's go 4 left. 1, 2, 3, 4. So that's 4 left. Right there. And then we're going to go 7 down. Gives you a sort of a hint. 7 up would be off the grid. So 7 down from 3 is going to -4, isn't it? So it's very difficult for me to see this. The screen, I'm just going to zoom in a little bit. -4, -3. It's easier on your paper. So that corner is going to be translated to there. Now how high is this? This is too high, so this is going to go from -4 to -2. Not very accurate. Let's just draw that a bit more accurately. Should do this with a rule, obviously. Okay, so, and the width goes from 1 to 5, so it's 4 wide. So it's going go down to this point here. Okay. And label, it says label your new triangle R. So there we go, R. Write down the vector for the single translation that moves triangle P to triangle R. Okay, so we want to go from this triangle P to R. So let's go across first. So we're going from -6 to -3. So that's 3 to the right, which is a +3 in the top part of the vector. And we are going, excuse me, we are going up. So from P to R? P to R, yes. And we go down, so this is going to be negative. We're going down from 1 down to -4, so that's a distance of 5. So we go -5. Show the connection between the vectors in parts A and B and your answer to part C. Okay, so what's the connection between A and B? 5 and -4. A, 5, 2, and part B, -4 to get here, 3. I've done something wrong here. Oh, I'll come back to that in a minute. Question 16. Water is poured into a tank. The graph shows the number of litres of water in the tank. How much water is poured into the tank each minute? So how much water per minute? Okay, so this is the amount of water, the number of litres, per divided by minute. Okay, so that looks like rise, number of litres, rise over 1. So it's actually the gradient of the line that we're interested in here. So we get a triangle. Any triangle will do. Let's pick one that goes through the grid points. And here our rise is 120. And our run is 8. 120 divided by 8. Which is that? Well, let's cancel down. Half of 120 is 60. Half of 8 is 4. 30 over 2. 15 over 1. So 15 over 1 is 15 litres. Question 17. Sanjit thinks that y equals 2x plus 3 and y plus 2x equals 5 have the same gradient. Explain why is wrong. Okay, so when you're talking about gradients, you always want these in the form y equals mx plus c. And you can see this second line is not. So let's sort that out. So what we're going to do here to get y equals is to subtract 2x from both sides. Okay, so this is, let's say, line 2, and line 1, of course, was y equals 2x plus 3. This has got a positive gradient, negative gradient, because of the negative gradient. Never mind what its value is, -2. This has got a positive gradient. Therefore, the gradients are not the same. Okay, next question. Circle the 2 roots of this. Now, a lot of people were multiplying this out for some reason. I do not know why. Because in order to solve the quadratic that you get from multiplying that out, you'd have to factorize it and get back to this again. Remember that 2 things multiply together to give 0 must mean that either one is naught. So either 2x plus 3 must equal naught, or 5x minus 2 must equal naught. And if we simply solve this by subtracting 3 from both sides, then divide both sides by 2, there's one of the solutions. That's that one. And for this, we add 2 to both sides and divide both sides by 5. So there's the second solution. And it says circles, so we're going to put a circle there just in case. It wouldn't matter, but. Question 19. The diagram shows a triangle and a trapezium. Prove that A equals B. Alright, okay, now this is obviously of interest. What's going on here around this particular bit? Well, what do we know? This is angles around a point, and we know they add up to 360. Now, look at these two angles. That's 65 and 115. That's 180. Okay, so if we wanted to, we could write that down. And here, what we're left with is A and C. So we know that A plus C plus 180 must equal 360. And if we subtract 180 degrees for both sides, we get A plus C is 180. Okay. Now, look at these two now, B and C. Okay, B and C. These are corresponding angles that add up to 180. Okay, so B plus C, because there's parallel lines. Okay. So B plus C must equal 180. And if that's the case, we could write them underneath each other. So this is B plus C, 180. And we're going to subtract one equation from the other. So we're going to subtract these two equations. Okay, so let's do that. So we're going to get A minus B. C minus C is nothing. 180 minus 180 is nothing. And just rearrange this by adding B to both sides. A equals B. Question 20. In 1 month, the number of hours exercise taken by 10 people are as follows. Which is the appropriate average to use in this situation? Right. This person is exercising relatively consistently for 7, 2, 6, 5, 1, and then suddenly goes mad. It's a marathon or something crazy, and then goes back to normal. Does their sort of normal, relatively normal routine. So this 82 really is a little bit of an anomaly. Okay, it's an unusual answer. Called an anomaly. And if you've got an anomalies in data, you want to ignore them, if you like, when you're doing an average. And what does that? It's the median here. So the answer is the median. Give one reason for each of the other two averages as to why they are not appropriate. So we've done mean, median. Now we need to say, well, why is median appropriate? So the mean takes into account this 82. Into account 82. And what that will do is we'll increase the average. Because of the anomaly, you shouldn't really do that. You know, if you said to somebody, how many hours do you typically, which is what we're talking about, the average, exercise each week? They're not going to say, I do 50 odd, whatever the mean is of these. We do 50 hours every month. They're typically doing about 6, aren't they? So we don't want that. And the mode. Why is the mode not appropriate? Well, there is no mode. All of these numbers have got the same frequency, so there is no mode. Question 21. A, B, and C are points on the axis as shown. The area of the triangle ABC is 28 square units. Work out possible coordinates for A, B, and C. Alright, well, this is a triangle. So ABC is a triangle. So area ABC is a half the base, okay, which is B minus A. That's that length. Times the C, times the height. So this is my base, and this is my height of my triangle. And we want the area to be half the base times the height. So we'll just put that if you wanted to. Okay, so all we need to do is to make it so that this area is half the base times the height equals 28. Alright, so we want half the base times the height is 28. If we multiply both sides by 2 here, we get base times height is 56. So if we first of all just fix this value, this could be anything you want. This could be 5.6 if you wanted to. Okay, 5.6. So this is going to be 5.6 on the x-axis and 0 on the y-axis. And A, well, this is on the y-axis, so that's going to be 0 there and 0 there. And we want this to be 10 now. You see, because we multiply 10 with 56 to get 5.6 times 10 would give us 56. So if we want this to be 10, then maybe this is minus 4 and this is 6. Adding up make a difference between minus 4 and 6 is the difference is 10, giving this length as 10. So what we're saying is this is 10 and this is 5.6, giving 56, and then because it's half of 10 times 5.6, that gives us 28. But any combination of this length multiplied by this length, then divided by 2, giving 28 would be a correct answer. 22, very badly answered question. It asks us to draw a cumulative frequency graph. Almost everybody did a histogram. So, to do a cumulative frequency graph, what do we plot against what? Cumulative frequency graph plots on the cumulative frequency on the y-axis, and these on the x-axis should be upper class boundary. So the upper class boundary on the x-axis versus the cumulative frequency on the y-axis. You must remember that, guys. Okay, upper class boundaries, the x-axis. So what are the upper class boundaries? They're these value here. And we're plotting against the cumulative frequency, which we don't have here. So the cumulative frequency are the frequencies added up as we go along. We accumulate the frequencies, cumulative frequencies. So if we accumulate the 6, and then accumulate the 16, add the 6. People can't add up 6 plus 16, which is 22. Add the 28, now makes 50. Add the 10 makes 60. Okay, now we're expecting 60 to be probably our total cumulative frequency, or our total frequency here. That's going to be 60. And then what we do is we're going to plot 50 against 6. So 50 against 6, that's going to look like 2, 4, 6. And then we're going to plot 60 against 22. So 60 against 22, that goes there. And we're going to plot 28 against 50. 70 against 50. 70 against 50, which is there. And we're going to plot 80 against 60, which is there. The only other point that we need to remember is at the point where we're here, right at the beginning, there are actually no frequencies of size 40, because notice this sign here. It's greater than 40. X is greater than 40. So at 40, there are none. So there's a point there, 0 frequencies at that point. Then we draw a nice smooth curve between the points. And the cumulative frequency curves are these sort of S shape. And that will give you your marks. Use the graph to work out the interquartile range. We need to remember that the interquartile range is Q3 minus Q1. Now Q3, you go 3/4 of the way up 60, which of course is 45. So up to 45. Plus here, use a rule. In fact, let me do that. Draw. And draw using this. So start at 45. We're going to go along and down. So I can't get that exact. There we go. There, that point there. So that's Q3, this point that I've just got to here. This is Q3. And Q1 is 1/4 of the way up 60, which of course is 15. So again, we're going to draw from 15. It's not quite accurate, so just do that again. It wants to move. I don't know why. Okay, imagine that that was on 15. This value is our Q1. So what is Q3? Our Q3 looks like 68. And Q1 looks like 52, 54, 56. Okay, so what we get there for our interquartile range is 68 minus 56, which is 12. Now, there would be a bit of tolerance for that. A little bit. Not an awful lot, but a little bit. 23. The equation of the curve is y equals x plus 3 all squared plus 5. Circle the coordinates of the turning point. We did this in class not long ago. Very few people got this right. If you recognize this as completed the square form, you should know the x coordinate of the turning point is solve this equal 0. So x plus 3 equals 0. That gives x is minus 3. That's the x coordinate of the turning point. And the y coordinate of the turning point is this. Just read it off directly. So x is minus 3. This one. Y is 5. That's why it's only 1 mark. You can literally just read them off. Put them in. Must remember that. So here we remember if y equals x plus a squared plus b, and x equals minus a and y equals b is the turning point. They might call that a maximum, minimum, sorry, in this case, a minimum, turning point. They might call it a stationary point, or they might call it a vertex. Vertex is a great name for it, but they do sometimes call it a vertex. We're basically talking about the point at which the curve, in this case, is going to be like this. That's where this point is, the vertex. This is minus 3, this is 5. Not drawn to scale, of course. Use the graph to work out the this is a repeat of what's been done before. Question 24. Here is a cyclic quadrilateral. What do we know about cyclic quadrilaterals? Opposite angles add up to 180 degrees. So let's write that out. So x plus 20 equals w. We know that for sure. And we know x plus 1. Sorry, x plus 20 equals w. So x plus 20 plus w is 180. And we also know that x plus y is 180. Right, what else are we given? We're given this information, and remember again, ratios, they're the same as divisions. Okay? We're trying to work out the size of angle W. So, what do we know about this? Well, first of all, we can use that in here. So we can rearrange this equation by multiplying both sides of this equation by y. So x is 5y over 7. And then we can substitute that into here. So this is equation, let's call this equation 1. This is 2. This is 3. Substituting 1, substitute 1 into 3. So instead of x, we're going to write 5y over 7. Now to solve this, we're going to multiply both sides by 7. So we get 5y plus 7y plus 7 what 8 is. 7 naught to naught, 7 8 is 56, and 5, 7 1 is 7 plus 5 is 12. 12 60. And this, of course, is 12y. So y is that. And what is that? Well, you can see by just dividing that out very quickly. 12 into 12 goes 1, 12 into 60 goes 5, so that's 15. So y is 15. Now if y is 15, sorry, 150, 150, sorry. If y is 150, then x must be 30 degrees. Because x plus y is 180, because y is 150. So x must be 30. Now if x is 30, we're going to substitute into 2 now. Substitute 2. So x is 30, so we get 30 plus the 20 here plus the w is 180. So here this is 50. Subtract 50 from both sides, and w is 180 minus 50, which is 130 degrees. I have a feeling I may have made a mistake there, actually. I'll just check that through. Let's see. X plus y is 108. 5y over 7, that's correct. 5y over 7 plus y equals 180, that seems okay. 7y, 180 times 7, let's see if I got that right. 7 naught to naught, 7 8 is 56, 6 is 5. 7 1 is 7, 5 is 12, that's correct. 12y is 1260, just check I've got 12 into 12 goes 1, 12 into 60, 12 into 6. Sorry, 12 into 6 goes 0, and 12 carry the 6 over, 12 into 60 goes 5. That's 105. That was wrong. Sorry. It didn't look right to me. It just felt wrong. So that's 105. Okay, and if that's 105, what does that make y? Well, 105 plus y, x plus 105 is 180. So we subtract 105 from 180. We're going to get left with 75. So x is 75 degrees. So we, instead of 30, we got 75 because we're doing 75 plus 20, and that's 75, 20 is 95, and w is therefore 180 minus 95. And 180 minus 95 is there and 85. Quite a lot working out there. Not easy. Question 25, vectors. Okay, express the vector b to a. So we want to travel from b to a. Okay, in terms of a and b. So to travel from b to a, we need to go from b to o. B to a is b to o, and then from o to a. We need to end up at the point A, starting from B. Now what is B to O? Well, it's the opposite direction to this arrow here. So it's minus B, the opposite to B. And then we're going to go up there, which is A. And minus B plus A is the same as A minus B if you prefer. Don't forget to underline your vectors. M is the midpoint of AB. Express BM in terms of A and B. So we only want to go halfway up. So if we go from B all the way to A, we're only going halfway. So that's just half of this vector. Question 26. 0.7 recurring is 7 ninths. That's something that you should know or could prove easily if you wanted to. Use this fact. Use this fact, that's important. How do we get from 0.7 recurring to 0.07 recurring? We simply divide both sides by 10. How do we get from 7 ninths to 7 90ths? We divide both sides by 10. So we're simply going to say 0.7 recurring divided by 10 is 7 divided by 9 times 10. We've just divided both sides by 10 again. And therefore 0.07 is 7 over 90. That's our mark. I think if you just wrote both divide both sides by 10, you might get part. Better to show it then. Using part A or otherwise, so or otherwise, we could do it two ways. I'll do it both ways for you. What we want is 0.2 and then 7 recurring. Well, you could realise that this is 0.2 plus 0.07 recurring. And 0.2 is a fifth. 0.07 is 7 90ths, as we showed up here. And then add these together. So that's a common denominator of 90. Adding fractions. 5 into 90 goes 18. 90 into 90 goes 1, so that's 7 there. So we end up with 25 90ths, which turns out to be 5 18ths. That's one way of doing it. Another way of doing it is to do the way of letting x equal this. Okay, and we multiply that by 10. If we multiply 0.2, 7 recurring, remember 0.2, 7 recurring, looks something like this. Multiply it by 10, we move the decimal point to the right, so it's 2.7 recurring. Remember when we're doing this, we're looking for the right-hand sides to be the same. Here they're different. This is 0.2, 7 recurring, this is 2.7 recurring. We want the recurring bits to be the same. Multiply again by another 10, so multiply by 100. And so there, that's going to go to that point there. So this is 27.7 recurring. And then we get 7 recurring on both this one and this one. So we're going to subtract here. 100 minus 10 is 90. 27.7 recurring minus 2.7 recurring is 25. And we've got the same answer here. (27) There are 11 pens in a box. 8 are black, 3 are red. 2 pens are taken out without replacement. Important. Put that in bold. Work out the probability that 2 pens are the same colour. You should draw a tree for these. You're not being very good at drawing these trees. So here we want the events across the top. So first pen picked, second pen picked, and along these we want the outcomes. So the first the outcomes for each pen being picked is either it's black or it's red. And the second pen, we get black or red, black or red. Just wait for 1 second. Alright, okay, so for the first one we got black. Okay, so there's 8 black out of the 11. So this is 8 11ths chance. And red there are 3 11ths. Notice that these add up to 1, by the way, and they should always do. So should these add up to 1, and so should these. Right, so the second pen. Now, if we've picked a pen already, there's only 10 left. If we've picked a black, the first one here, so there's only 7 left out of the 8. Makes this 3/10, so that they add up to 1. If we pick a red and another red, well, there's only 10 of them left, and there's only 2 reds left, which makes this 8/10. Probability of the same colour. Probability of the same colour. They must both be black, black followed by black, or, which is plus, red followed by red. Okay, so black first, and these are multiplied together, these are and, black and black. And is multiplied, so remember and goes with multiplied, or goes with plus. So here we go, black 8 11ths times black 7/10, red 3 11ths times red 2/10. This is, we can cancel it out if we want to, 4/5, 1/5, and then we'll cancel them to be done. This is 28, remember multiplying fractions, multiplying numerators, multiplying denominators. And this is 3/55. Add them together and you get 31.